So C++ compiles into ones and zeros for the CPU, right? It's an actual compiler, as opposed to Java, which is an interpreter. So probably faster, arguably not as portable. C++ is a little closer to the metal in that sense, right? C++ is also older. And for me personally, C++ never seemed as consistent as Java. And people will say Java has lots of inconsistencies, but most of what Java does, to me at least, makes sense. C++ seemed to have some kind of arbitrariness to it that's fairly subjective. C++ also lets you do things like operator overloading. So I can redefine the star symbol, for example. Normally that's multiplication. If I have my own type of variable like a fraction, I can actually make a method and call it star. And if I say fraction 1 star fraction 2, it'll call my method, my code, and I can use that to multiply fractions. So that's a feature people used to get really excited about, being able to overload operators. So yeah, that would be my first answers, I guess. All right, definitely no basic Java syntax. Again, I'm not going to totally kill you on, you know, a missing semicolon here or there. But 10 weeks of writing Java code, you should know most of the essential syntax. So definitely public static void main, parentheses, string bracket, bracket, variable name, close paren, curly bracket, blah, close curly bracket, right? You should be able to do that in your sleep. Possibly you already do. Try catch blocks, if thens, for loops, while loops, variable declarations, stuff like that. Defining a class should all be pretty familiar to you at this point. And I'm probably not going to nickel and dime you on syntax, but if it habitually looks like you've never actually written Java code, like you've just been using an IDE, it'll probably come out. So just review that. All right, so classes and methods. So everything's a class, right? So class, name of class, curly bracket, body of the class, closing curly bracket. That's how you define a class. And methods are really just functions. Okay, so type of return argument, void if it's not returning something. Name of the function or method, parentheses, argument list, curly bracket, closing curly bracket. Body goes in between. So very much like C, class is very much like a structure. Creating an instance of a class, right? Again, it's kind of like a structure, but we don't have to say struct my structure or class my class. If we have a class called my class, we can just say my class X, and X is a my class. Okay, so it looks just like an int or a char or a double or anything else. And then accessing variables and methods from an object, again, it's just like C. If X is a class, you can say X dot, name of a field in there, or X dot, the name of a method in there, and access the pieces of your class just using a dot. So there's no arrow notation to worry about because we're not talking about pointers, even if we are. So signatures, right? So this is a little unique. So in C, the name of a function specifies that function uniquely. In Java, the name is only part of what specifies a function. There's also the list of what types of arguments it takes. So you can have two functions with the same name but different types of arguments, and they are completely different functions. Don't have to have anything to do with each other. Usually they do. So we call that combination of the name and the types of arguments the signature of a method. And as long as the signature is unique, it's a unique method. And when you call a method, it looks at the name, type of arguments, and it uses that signature to find what method you're calling. Static and non-static. So I think we worked through this for the midterm, but basically if you have a class, so classes are not static, okay? Methods and fields can be static, but classes are not static. So class me, integer x, static integer y, void some function, static, say void some function 2. Alright, so we got some statics, which we can also call class variable, and a class method. We've got non-statics, which we can call an instance variable or field, and this would be an instance method. So if we say m is an object of type me, right, we can say m.x equals 5. We can say let's run m.fun. Those are all perfectly valid. These things, x and fun, are being accessed as part of an instance of this class me, right? So m is an instance. But even if we don't have an instance of me, we can still access the variable y by just saying name of the class dot variable. Okay, and that's a static reference to y. Or we could say name of the class me dot function 2. And it's a static reference to a method. So non-statics or instance references, right, you have to use an actual object of that type to access. If you're not using an object of that type, but you're actually using the class itself, that's a static reference, okay, or a class reference. And so most of the functions that we write turn out to be like this. Most of the functions, most of the fields that we use in a class, they're instance references. But occasionally we do things like this, for example, math.square root. Did we talk about construction already? Different versions of constructors. There we go, it's next. So constructing is like doing a malloc in C, right? You construct an object. Right, so if myRect is a class, myRect_r says r is an instance of a class myRect. Right, it says r is an object of this type, but r itself is null right now. So if you want to use r, you've got to construct the object, and depending on how the constructor is written, you may have 0 or more arguments that you pass to the constructor. So that declares r, this actually constructs the rectangle and assigns it to r. And you can do that in one step. And so typically you might have a variety of constructors that take different types of arguments, different numbers of arguments. All right, data structures that we've worked with. So we've worked with arrays. We've worked with lists, linked lists, trees. We played with some decision trees. We've done some recursion. And there'll definitely be some recursion on the test. I don't need you to know the details of classes like linked list. You should know they exist, but if I asked you to do something like, you know, use the linked list class and construct and add some elements to it, I would give you some documentation that looks like this. Okay, so I don't expect you to know the Java documentation for all these different classes, other than a few of them like string, right? String I want you to know how to use, scanner I want you to know how to use, etc. We'll talk about those. But you should know that we can implement linked lists and hashes and stuff. They also come pre-supplied in Java. And that ties into the idea of generics. Okay, so generics, remember, if we do make a linked list can consist of different types of objects. So when you construct a linked list, you have to specify what kind of linked list. So we would say something like this. And this becomes kind of a embellished class name. So it's the name of the class, and then in angle brackets the type of thing that we're putting in this linked list, for example. If you make a hash map, which has two types of data, it deals with keys and elements, right? When you define a hash map, you have to put two of these things in angle brackets. The type of data that the key is, the type of data that the elements are. So that's a generic, okay, and these things work with different types of data, and you specify those types of data when you use the class name and when you construct the class. So hash maps take a key and a value. I don't think we talked about how to actually write generics, do we? We might do that later this week. It won't be on the test, but we might touch on that just because it's fun to do and it's pretty easy. Alright, the other concept we talked about was iterators. And so this comes up, for example, with hash maps. And it's a general concept, right? You have some data structure and you want to pull things from that data structure one at a time. If it's an array, it's easy to do that yourself. You just have an index, start from 0, go to the end of the array, and it gets you successive elements. If it's a linked list, it's fairly straightforward to do that if you have a way to go from node to node. But with some more abstract structures like hash maps, where there's no natural ordering to them, or maybe your word array that you built in an early PA, if it wasn't alphabetized, there's no natural order to these things. Right? And so an iterator is a mechanism you can use to pull things from your data structure one at a time. And basically you construct an iterator and you can say while has next, and you can say next to get the next element. And the specifics of that depend on the thing that you're iterating on. So for a hash map you can say give me successive keys, and then you can use each key to fetch the corresponding piece of data. But it basically works like a scanner. Right, you can say has next, and as long as it has a next, you can say next to get the next element. I should have had you write some iterators. I'm going to do that next year. You don't have to come back for that. Okay, so I definitely want you to know how to use strings. You've already seen this on the midterm. You've seen this on other things, right? So strings, you should know how to find the length of a string, how to tell if two strings are equal, how to compare strings alphabetically, how to find a character at a particular position in a string using character at, why we use equals versus equal equal, right? Because equal equal checks to see if two objects are the same object. Dot equals tells us if the characters in the two strings are the same. And then the toString method. So toString is a method that's always available for every object. And when you concatenate a string to an object, the system calls the toString method of that object to turn it into a string and then concatenate that. So you can explicitly if R is a rectangle, you can explicitly call r.toString, and that'll return a string, right? But if you have, you know, a string, and you concatenate R to it, that's implicitly saying I want to concatenate r.toString, right? So it calls it for you. And usually we use this to create a string that somehow represents some useful information about the object. So you've written those, you've used those, right? So you should be pretty fluent with those. All right, arrays. So arrays have a few odd things. Right, declares data to be an array of integers, doesn't actually set up space for it. So if you try to use data, you're going to get an uninitialized exception from the compiler. I'm going to get in trouble here. I'm not going to try to do this by memory. I thought there was a shortcut way to do that. Okay. So data equals new int Alright, so this declares an array, but it doesn't have any values. This actually constructs an array of 10 integers and sets data to be equal to that array. Right, so if you don't actually do that new construction, it tells you that your array may not have been initialized. So it'll save you from yourself. So for primitives, this works fine. If you have things like rectangles, okay, where rect is a class, this sets up an array of 10 rectangles, so data is now 10 references to rectangles, basically. But if I try to do something like data bracket 0.toString, right, I'm going to get a null pointer exception. I almost said segfault because I was just teaching 121. You're going to get a null pointer exception because data 0 is not actually a rectangle yet. It's declared to be a reference to a rectangle, but we haven't given it a value. What we've basically done was the equivalent of saying, this isn't valid syntax, but you know, we've said this is going to be a rectangle, but we haven't actually constructed a rectangle. So before we can do this, we would need to use new again. And actually construct our rectangle with whatever arguments the constructor needs. So this is constructing the array, basically. This is constructing the individual element in the array. So that's the only kind of slightly quirky thing about this. You end up having to do new twice, but not for primitives. And then there's automatically a field anytime that you have an array. So I can say data dot length. And that's just a field in this object, which in this case would give me the number 10. Right? And it's not data.length parentheses, which is calling a method. Unless I have a method in here called length, that's not going to compile. But data.length, not with parentheses, right, it's just accessing a field, and every array has a field called length that gives you the length of the array. And now I'm curious. Yeah, I'm going to try that. Alright, so I think that was where we got through on the midterm, more or less. And then post-midterm we started talking about, well, we had done some scanners before. So scanners and PrintWriters, right, these are ways to do input and output in Java. And again, there's a whole hierarchy of input-output. Yeah?
So when we have bracket, what's length without bracket?
So for example, with a string, we can do this, right? This is calling a method inside this class string, okay? This is not calling a function, it's not calling a method. This is just a field, right, inside this array, right? So it's just a number. So we can do right, so that second one is not going to compile, that second statement, because there's no method called length paren inside x. But if we get rid of that, right, x.length will give us the number 10. So that's all. Alright, so scanners are a way to get input, and I'd like you to know how to construct a scanner. I'd like you to know how to use hasNextLine and nextLine. Okay, and pretty much everything that we've done in this class for reading input was doable with hasNextLine and nextLine. Okay, now there's more that you can do with scanner. You can do hasNext, you can do hasNextInt, hasNextDouble, and so on. But if you just want to read in a line like you would with fgets in C, all you need is hasNextLine to know if there's anything available, and then nextLine to actually get the next thing that's available. And if you are reading from standard in and you hit Control D, or maybe Control Z if you're in Eclipse, hasNextLine will come back with false. Okay, because you hit the end of the file. And if you try hasNext without hasNextLine, it will throw an end of file exception, saying you're trying to get the next line, but we already hit the end of the file. So scanner s equals new scanner parentheses system.in sets up a scanner for reading from standard in, and that's our most basic way to do input. But you can also construct a scanner on a file. So scanner s equals new scanner parentheses new file parentheses string containing the path name to a file will open up that file for input. And you'll be forced to throw that inside a try-catch block in case the file doesn't exist. The scanner construction would throw an exception. And then once you've opened this up on standard in or on a file or on something else, a socket, whatever, you can just do has next line, or whatever your preferred way is to ingest data. PrintWriters go in the opposite direction. So construct a PrintWriter on, you could do it on system.out, but we don't need to do that because we can just say system.out.println. But if you want to write to a file, we can construct a PrintWriter on a new file. Same thing, put it in a try-catch block in case you can't build a file. And then when you say PrintWriter.println, it writes into the file instead of standard out. And you can do println, you can do print. And then I'd like you to be clear on this concept of buffered I/O. Right? The fact that when you write a bunch of things into a file, it doesn't necessarily appear right away. And in fact, when your program exits, things that you've written to the file may not have actually gotten into the file. And if you close the file, the PrintWriter in this case, it will force everything that's been saved up to be written to the file. It will force that to go into the file. Right? But it buffers up I/O. It saves up this stuff that you're asking to write until there's enough of it to make it worthwhile, and then it writes it out all at once. Or you close the file in which it says, well, you're done with the file, I'm just going to go ahead and write this stuff out. Or you call the flush method, which says, hey, this person really wants me to write this stuff to the file. Even though I've only got 10 things to write, I'm just going to go ahead and write it out, because they call it flush. And there's a whole hierarchy of input-output in Java. And there's streams, and there's writers, and there's buffered writers, and there's all kinds of stuff. There used to be a nice map I had. Yeah, like this. So there's buffered and data input streams and output streams, and those are extensions of lower level input and output streams, byte arrays, and those are all derived from input stream or output stream, which are objects. So there's this whole level of inheritance. And different things happen in different of these classes. The degree of buffering, the degree of interpretation of the data. If you write an integer, does it write it as 4 bytes, 32 bits, or does it write it as a series of ASCII characters corresponding to the value of that integer? PrintWriter will let you actually write out the ASCII codes for, say, an integer. Low-level writers will just spew the bits out. I'm going to save this picture. Alright, so scanners to come in, PrintWriters to go out. So class extensions, we've played a little bit with this, but we actually used it a lot when we were doing GUIs, because we had to extend things like J-frames, right, to make our own versions of these. We also use this in threads when we wanted to extend the thread class so that we could have a run method in our own classes. So class extensions, basic setup. Class, new class. Extends old class. So it's a modifier on the declaration of a class, which says I'm creating a class called new class, but it's actually an extension of this pre-existing class. And in effect, everything that's inside old class is now inside new class as well. So if there's a method in here called blah, and I don't write my own method called blah, I can still say new class blah, right? It's a method available inside here. But I can also write my own versions of things that were in old class, and I can write new versions of methods or fields that don't exist in old class, right, that I want to have part of new class. So it kind of starts with this base class and then lets you add things to it or customize what was already in here. And so thread is a good example, right? We make my thread that extends thread. It's got all the machinery that thread has, is alive and join and stuff like that, and a default run method, but we can write our own run method, and it overrides what was in the thread's run method. And that's how we make threads, basically. Same thing with JPanel, right? We want to make our own JPanel that we can do some painting with. We override the paint method. We'll get to that in a bit. So we extend JPanel, call it my JPanel maybe. We override the paint method so that it does our painting, but we don't want to override the set size method and all the other methods that go along with the JPanel. So we just put in the things that we want. And there's this keyword super. So I've got some integer called data, right? And somewhere in my code of some method, if I access data, I'm referring to this field, right? Unless data is defined in here locally. But remember, there was perhaps an integer named data in my old class, right, that I extended. If I want to get to that, I can say super.data. And if there's a method in the old class that I've overridden, I can get to that by saying super.methodName. So maybe I make my own toString method, but I want to use the toString method from the original class. I could say super.toString, and that would run the toString method in there. So you're not really replacing those methods, you still have access to the originals. Alright, exceptions and exception handling, so try, catch, otherwise. And you probably got more of this than you want for your whole lifetime in dealing with PA5. But try, there's a try block. Catch, here's a catch block. Otherwise, and there's your otherwise block. And so your catch block takes something that looks like an argument. So you need a type of variable and the name of a variable. And if you get an exception in here of the same type as an argument in your catch block, then you jump down into your catch block and run. So I could have EOX exception, array bounds exception, different things like that. But anytime you've seen me do this, I'm usually just doing exception, which matches any kind of exception. And then this, I always call this E, but it's just the name of a variable. It's like an argument to a function. And so inside here, E will refer to the exception that caused me to jump from my try block to my catch block. So you execute the code in here. If you succeed, you come down to do the otherwise block, and then you're done. If you get an error, you jump down, you do your whole catch block, and when you're done, you come down to otherwise. And if there's a return in here, you still come down and do your otherwise first, and then you go back and return. That's the weird part. And you'd like to keep your try-catch blocks as small as possible, right? You get errors from the compiler saying this might throw an exception, you need a try-catch block. So you put try as the very first line of your program and catch as the almost last line. It gets rid of the error, right? It lets you compile and run. But it's really not what you want to do, right? Because if there's 5 different things that might cause errors in your program, if any of those happen, you jump down to that one catch block, and you don't really know like where you were and what happened. And so usually we don't want to just, add stuff to our code so it stops complaining about possible exceptions. We want to make sure that we handle possible exceptions, right? So that your program doesn't say rip in space-time continuum. So we usually try to put these blocks just around, maybe just one statement that might throw an exception. And you've seen me not do that, right? Because it's faster to just make one try-catch block. But if you want to be right about it, right, you would make them as small as possible usually. All right, so let's call it a day for that. Let's continue on with swings, swing GUIs, and so on and so forth, taking us up to threads and sockets. And then we'll probably have some time Friday to talk about whatever.